Welcome everyone for another lecture of your industrial automation lecture series. Today is an interesting and quite important topic regarding PLC programming, which is about timers and counters. So this is your sixth lecture on PLC industrial automation, and I think this is the second one on PLC programming. In today's lecture, we're going to cover the three different timers that is used in most of the PLC programming. The first one is starting from T on or the on delay timer, and then we move into the off delay timer, which is also known as T off, and finally we have this pulse timer, which is also known as TP. Right. So there are plenty of timers available in many automation applications. They could be either analog type or developed using clocks modules and like that. But when it comes for PLC programming or microcontroller programming, you have seen even in the Arduino, you're using timers and delays functions. So internally, this microcontroller devices has clock, internal clocks. They're running and generating pulses, and this internal functionality of these timers is quite important. And it is counting number of clock pulses, and based on the clock frequency, it can determine the amount of time. Similar to the microcontrollers, in PLC, we have quite handy and quite simple way of using timers. So they are just graphical representation as a function of blocks. In programming, we're just using the standard text type, a delay function, and like that. But for here in PLC programming, so in ladder diagram, we are just using timer blocks. So when you open your simulation or the codices environment, I will demonstrate how to open this timer module. And before we move into the few practical examples, let's take a look at how this timer module works and how about its input and outputs. First, this timer function block, it implements an on delay timer. So you can see there are two inputs. First one is the in, so which is to enable this timer. So if it is 0, the timer will not work. So if you enable and if it is get true using this in pin, so the timer 1 starting is counting. And this is PG is your defined time. Like in your microcontroller, you set a delay time. Like in here, you have to define your amount of time duration that you want to start your application after 5 seconds, right? And Q is your output. When it meets this time duration, your defined time duration, so the output will be enable high. And ET is escalated time, which is displayed when the timer is, when you enable this one, it is counting its time like a stopwatch. So from the escalate ET pin, you can just take this variable, the current time of the timer, and you can display it using a text file. Like I mentioned, the output is either it could be 1 or 0, depending on the status of the timer. So that's Boolean type. And so there are a few ways of defining the time delay. You have seen in the Arduino programming, you just type 1000 milliseconds, 1000 like that, right? So if you want to define the delay in seconds, you just type T hash and your time 5 seconds, right? And if you want to display, define this delay in milliseconds, the way that you want to define is, for example, for 500 milliseconds. So you should type T hash 500 and ms. That is 4 milliseconds. For seconds, it's just 3s. So all the time, in order to define this delay, you have to additionally add this T and this number sign. So T and the number and this your time delay. So if you want to display the seconds and the milliseconds. So you can just type 3 seconds and 500 milliseconds. And if you want to add the minutes into your delay, so you can just add it as M. And if you want to add hours, you can just add as hours. And if you want to add days, you can add even days to your delay, right? So if the program is running too long, so you can add delay even in days. So this table demonstrates you how to define the time duration of the delay. And now you might have very basic understanding about the input and output. So we have this enable pin to start the timer, and we define the time delay from here. And this is the escalated time, which is when the timer is starting, it's displaying it is like a stopwatch, how this time is counting, and when it reaches the 5 seconds, so the output will be set to high. Right. So this is the simple behavior of a T-on timer. Sorry for that. Okay. So T-on, sorry for the interruption. So as you could see here in the timer block, so initially you have to give a input pulse or any high signal to this input pin where you start your timer. So you have to keep this input signal high all the time in order to keep this timer on, right? So let's say now it is starting from here. You give this enable normally open contact is now closed, and this in pin get high, and then so the SET elapsed time is just starting is counting. The time is now counting the time, and it is counting, and it is current time is updating, and then it reaches to 5 seconds. Right? When the time is reached to 5 seconds, the output Q1 will be set to high. Before that, the output is always 0. If you have 0 input, the output is always 0. And when you enable this in pin high, so the starting point or the rising edge of the in, so the elapsed time get increasing and it counting up to the 5 seconds. This is your defined time delay. And when it hits to 5 seconds, the output Q1 will be high. And the output will be set to high until this in is at the state of high, digital high. So whenever you just remove this enable or the in pin to low, so the output will be gone to 0 again, right? So you have to keep, when the input is 0, the output will be always 0. When you set the input high in the rising edge, the time is starting counting is time. When it hits the defined time, for example, is 5 seconds. So the output will be high. So until you keep this as high, so once the elapsed time reaches to this defined level, the output will be set to high. So whenever you remove this in pin to 0 or set it to 0, the output goes to 0. Now in this example, you set the input to the high, and the time is now starting the count in the time, but you just remove this pulse here. So you disable or you set this in pin to 0. At the same time, the timer is just stop its counting and it is reset back to 0, right? So you have to keep this always on until this gets completed its time counting. Now in this case, again, you set it to high. The input is high, so the timer is starting counting, and it is elapsing time and reaches to the defined time, and the output gets 0, and output will be high all the time until you remove your input enable pulse, right? When the output is removed, when the output is set to 0, when the input is set to 0, the output will be automatically 0, and the elapsed time also get to 0. So this is the basic functionality of the T-on timer, and I hope you will have a very good understanding about how this works. And if you have any questions, you can ask now. Or we can simply watch a simple demonstration from YouTube how this TO timer is working on the Codices simulation environment. Let me play the video, then you can visualize how it works.
On-delay timer, TOM. So basically it works like this. The output turns on after a delay. This is how it looks like as a function block. You see that it has 4 pins, one input, which takes a Boolean data type, one output, which also takes a Boolean data type, a preset time or PT, which takes a time data type, an elapsed time or ET, which also takes a time data type. The preset time is the delay for the timer. Remember that this timer works like this. The output turns on after a delay. The PT or preset time is exactly that delay. The elapsed time is how long the timer has been activated for. These two time data types has a certain notation, and it goes like this. You have to write T hashtag and then the amount of time. This is the notation. The time data type is the time in steps of milliseconds, but you have this notation with T, and then you can write the number as seconds, minutes, hours, even days. So let's take a quick look on how it works like. Remember that this on-delay timer turns the output on after a delay. So let's start by just turning on the input. And you can see what happens here is that the elapsed time started to count. You can just see it started to go up a little bit towards the PT. After some time, the elapsed time has reached the PT or the preset time, which was the delay for the timer. And that means that the output will also be set now. As soon as the input is deactivated, the output will also be deactivated, and the elapsed time will be reset to 0. Let's try to turn on the input again, and you can see the elapsed time started to count again. But what will happen if we turn off the input before the elapsed time reaches the preset time? So before the delay has happened. Well, as soon as you turn off the input on a on-delay timer, the elapsed time will be reset immediately. So you can see here, the output will never be set. Again, when we turn on the input, the elapsed time will start counting from 0 again towards the PT. And then when it reaches the PT or the delay, the output will be set again until it is reset only by deactivating the input. So here we are in Codices, where I'm gonna illustrate how the on-delay timer works with a simple simulation. As you can see, I've put in a function block here, which is an on-delay timer. I gave it a name, and I gave it a Boolean input to enable it. Now here at the PT or the preset time, this is where we will set our delay for the timer. And remember T and then the hashtag, and then you can put the amount of time that you wanted as delay. I'm just going to put 7 seconds here because that will be a decent amount of time to see how it works. Here goes the elapsed time, and we need to put a time variable here. We can just call it TON, elapsed time. There you go, and it will be of a time data type. There you go, and let's try to build this and go online in our simulation. Fantastic. And then we're going to put the PLC in running mode. And what you can see here is that the output is false. The input is also false. The PT is still 7 seconds, but the ET is 0. Let's try to turn the input on and see what happens. You can see as soon as I turn the input on, the elapsed time started to count. And as soon as that reaches the 7 seconds, as we put over here in the delay, the output will be activated. So let's try to turn off the input again. And you can see as soon as I turn off the input, the elapsed time will be reset and the output will also be reset. Let's try to turn the input on again, but this time, before the elapsed time reaches the 7 seconds, I'm going to turn the input off again. And let's see what happens. It started to count, but now I'm going to turn it on again. And as you can see, the output was never activated because I turned off the input and reset the elapsed time before the 7 seconds. Let's try just one more time here. I'm going to turn on the input, and remember, after a delay, the output will be turned on. And that is how the on delay timer works.
All right. Now we can just make a simple practical example using codices. So all you need to do is just test this simple ladder diagram using codices. Open your codices environment, and you can import a timer block and put a normally open contact. And this could be set enabled using a graphical visualization using a push button here. I'll show you how to do this. And we can set this the output also as a light bulb, so we can see how this timer is working. All right, so let me share this the simulation example. I hope everyone can see my screen. Here I have imported a timer block. So if you want to add a timer block to your module, so let me show you to add a new right. So first thing is you can just add a timer block. Just go to this one, insert a box, a functional block box, and so it is. When you go there, it will import several functional blocks. And click standard and this timers, and you can pick either T off or T on and TP. So since I'm using T on timer, I will select T on and then click OK. And it is coming as like that. So since you have to name your timer. Like if you have multiple timers, you have to name them accordingly. Like if this is T on 1, I should name it as a different name. Otherwise, the compiler will gives you error message. So you can name it to any name that you wish to have. And so here, so this keep this all to default. This is a timer, and type is T on type and set it OK. And this one here, you have to define your time. So here I have defined it at T hash 5 seconds and 100 milliseconds, 5 seconds and 100 milliseconds. Just type it as like this, T hash 5 seconds, 100 milliseconds, and then type enter. And this one should be set to any parameter variable that comes from the input. So you can type any name that you wish to have, like set en or something. And since it's a Boolean variable, you have to set OK, Boolean. And here you can add a coil, output coil. So name it as any name that you want to have. T1 0 out, something like that. And since this is coil is also Boolean, so keep it as Boolean and set it OK. And elapsed time, you can set any variable that you want to have. Like I'll just type time hash T1 0. So it is again the output type is time because it's displaying the time. You have to keep it as same. That is all about inserting a timer block as well as defining the inputs and outputs. So here we have the input to enable the timer, and this is our time delay, and this is our elapsed time, which is the counting and displaying the current status of the timer, and this is your output. So since I'm just using this one, I will just remove this one. And in order to visualize, you can either add any graphical representation here or lamp or switch. You can add any power switch. And here I will show you, last time I have shown you how to use these basic switches. Here we will try to do something different, like this kind of push button. So go here. And just use the button and drag and drop here. And you can type any name you want to have. And so this is a simple, in these lamps and switches, it only has one state. Either turn, it's like when you set it to one position, it remains in the same position. It's not it's simply a toggle switch. But if you want to have something like a momentary push button, when you're just pressing, it will just keep pressing until you keep your mouse on. So here is how you do this one. Just go to the command and insert a push button. And now, like you have to define which variable that you wish to control in your ladder diagram, right? So double click. So it will come this property menu. And here, go to the tab, right? So it is showing in here, input and output, input out configuration, and the tab and the variable. You can set the variable in the application PLC program. This enable one is this input, so you just use that. So this push button is, now you can control this enable using this push button, right? So same thing is I have already done here. So if you can see here, that program enable this set here. Now it's all ready to demonstrate this one. So all you need to do is build your project. Right, so I have 0 errors and 0 warnings, which is my program is good to go. Then I have to log into the PLC, virtual PLC environment. make sure you are in the simulation mode. Now all you need to do is just start the simulation, go to debug and start. Right. So when I press this one, it is enabling this input of the timer. So I can just press this one. So you can see the elapsed time is now counting, and it's counting up to 5 seconds. When the 5 seconds reaches, the T on output will be at 5. So when I take my hand out from this momentary push button, the enable becomes 0 and the timer is reset to 0, right? So again, when I press, it is counting, and if I release my hand before it's set to the defined time or the preset time, so the output will the elapsed time goes to reset and the timer again resets, right? So you have to keep enable this enable pin all the time until if you want to wish the timer get to its completes its elapsed time to the preset time, right? So I'm just pushing this, keeping my momentary push button on all the time. When I release it, the output will be 0. So this is the simple demonstration of this T-on timer. Now, if you have time, just I will give you 10 minutes. Go open and your codices and just import this timer block and define this time to 5 seconds and add the simple contactor here and make a push button. Then you can just simulate and see how it works. So I'll be here, and if you need any assistance, I will let you to share your screen and figure it out and just try by yourself. So now it's 10:40. I will give you 10 minutes to work by yourself this example. Again, the T off time is the second type of timer that we're using in PLC programming. So here, so we have the same inputs and outputs, but the functionality is a little bit off. Sorry, here it should be there's a mistake. You should be corrected to as T off timer. I have used the same inputs, and this is your delay time, and this is the elapsed time, and this is output. It should be corrected to the off. Right. So T off timer is also available in the functional block, so you can just get it there. Okay. Now we have this T off timer. So in here, when you turn on your input enable pin, the output is immediately goes to high. So the T off time is to turn off the output after a certain period of time. Here we have defined 6 seconds. So every time you set your input high, the output goes to high. And so no matter when you just remove your output, so the output is high and it's rising. And so the output is goes high, and the elapsed time is starting counting the time that you just turn off your input, right? Which means like when you turn on this one, the output get high. When you release or turn off this one, the output will go off after 6 seconds. The output will be set to high for a certain period until you just reset time hits. Here it is showing like when you set the input high, the output goes to high, and the output will be high, right? Input is also high. When you release your input, when you disable the input, here the time is starting counting. So the output is high and output will be turned off after 6 seconds when the input goes off, right? So when you turn off the input, so the output is turning on after 6 seconds. Now, after this one, the output is 0. Again, you set the pulse to the input pin and you release it. When you release it, the output is high. Now the elapsed time is starting counting after you release your enable pin input, and it's counting. And if you again set the input high, so the timer get reset, right? So you have to turn off your timer, then the timer is activated and turn off the output. Now you can see in this example, it's set to high, and it is keeping its output high until the input goes 0. So by the time the input goes 0, the elapsing time is starting counting, and after 6 seconds, your output goes to 0, right? So it is turning off when the input goes off after certain delay time. Now you can simply use the TOF timer using codices. This is how you import it to the environment, and using a toggle switch or any push button, you can just simulate it. And I will show you how to simulate this one as well. If you wish to open import a TOF timer, go to insert box, go to standard and timers, and TOF is available here. Then click it and import here, and defining your delay time and the output. And for the graphical visualization, I have used a momentary push button, and so I can just go online. I have already compiled this one, so I know there's no errors. Go to debug and start. Right. So I will just press the enable one. So you can see when I press the enable, the output goes to high, but the elapsed time is still 0. So I have to release this enable one. So I just leave my hand. So then it is starting trying to counting, and the output is to 0. And after 6 seconds, the output goes to 0, right? So by the time you press it, output goes high. When you release it, then only starting counting, and after certain delay, 6 seconds, the output goes to 0. So that's the simple way of using a TOF timer. So you have to give the input here and define the delay time, TOF time delay, and this showing the elapsed time or the stopwatch type of time, and this is your output. When you press this enable, so immediately the output goes to high. When you release it, the time is counting, and it is going to turn off the output after the delay. Right. Okay, now you can try by yourself, just importing TOF timer to codices using the same method, and you can get the results like how I did here, right? And so this is all about the TOF timer. The next topic will be pulse timer, so I will discuss that in few minutes. Same time, I will recommend you to just open the codices and try to do this by yourself. And we will have a short break, and I will meet you around 10 past 11. Meanwhile, you can try this by yourself. If you face any difficulty, you can just ask from me. Okay, everyone. Now this is the final timer type, which is the pulse timer, TP timer. Here we have the same parameters, the enable pin and the preset time, and the elapsed time, as well as the output in Boolean type. So TP time is represented as TP functional block. this is how it works. First, you have to provide a input high signal at the input terminal, and you have to define your preset time. And by the time that you enable your input high, so the output goes high as the T off timer. But no matter you just keep the input high or low, the output will be enabled high, and the output goes to zero after the time delay, right? So when the input is high, the output goes high, then the elapsed time starting counting right after the same point of the all the input goes high, right? So this elapsed time start counting from here, and it reaches there, then the output goes to zero, and here this output is becomes zero no matter what will still happen there. And when your input goes to zero, so the elapsed time also goes to zero. Now in this example, the input goes high, the output also should goes high at the same time. That elapsed time is keep counting, and no matter you just turn off it or turn it on in multiple times, the elapsed time is counting until the output uh, goes to zero, right? When the output is zero, so the elapsed time is good is to zero uh, because they enable this at zero. In this example, you just set the input high, the output goes high, the elapsed time is starting counting, your input is at the high, and when it goes to the reaches the preset time, the output goes zero and the elapsed time remains the same. And when the input signal pulse goes out, the timer resets. So it is very simple way of using this timer. If you is your choice, either you go for T off timer or T pulse timer. So the pulse timer, no matter when you just remove your input pulse, it is just keep counting and the output goes to zero after a certain time, right? So this is how you import a TP timer to your simulation model. Just type TP time in, just use functional block and just select the TP time. Right, so I will show you how to use the TP time in simulation. It code is this example. Here I have this TP timer, the same way that I have, I'll show you how to insert this one. Go here, select insert box, and go to standard timer and TP, right? So if you wish to see the how this works or anything, you can see this variable type. And if you want to look at any type of timer, just go to help, search right, then you can just search at the type TP, then it will show the description of how this works, but I have already explained that one. In order to visualize the operation of this one, I should go to online. Then go to debug and start. Right. So you can see, like, I will press this enable button. So it's starting counting for 6 seconds. So the output will be 0. So I have just pressed so the elapsed time is still remains the same. So if I remove the enable, the timer resets, right? So I will just turn this on and off momentarily like this, right? So it is still, the output goes high and it is counting until the reset goes there. And it's out. So when I release my hand, so then it goes 0. So the time that I press this one, it is starting counting. No matter your output goes high, or then it resets at this. If I do anything, it doesn't matter. Right, that's all about the pulse timer. And so I will show you some more examples now. Right, so you can use the timers as cascaded timers, which means you have multiple timers. For example, I have used 3 timers here: T on 1, T on 2, and T on 3. So each timer has its own enable, start, and for the T on 1 output, right? So I can use this output of T1 timer as the enable or the input of the T2 time, right? So this output is the output, the normally open contact of this coil. I can use it as the input to the T on timer. And here I have the output of the T2 timer, and this the contact, one of the contact of T on timer, I can use it to the T on 3 time, right? Then I can add another outputs combined with the more contacts of T1 coil, T on 1 coil. So T1 on coil output, normally open contact is connected to another Q1 output, and here this coil contact is connected to the Q2 output. Likewise, I can use multiple times. So the cascaded means the output of this one could be used as the input of this one, like that, right? So in order to demonstrate this one, I have used this visualization. I have used this start button as my push button or toggle switch, and Q1, Q2, Q3, I have used pilot lamps, and I will demonstrate you how this works. Now you can log into the PLC using Go Online. Log into the PLC, then go to debug and start the code. So you can try this one by yourself. So the same program that I have explained earlier. I will go debug and start. So I can now see this is my start button to start the T on timer, and the output of T on timer is used as the input of T on 2 timer, and output of T on 2 time is used to the input of T on 3 time, right? So when I start this one, so this timer will start counting. You can see now it is high, and after 3 seconds this Q1 goes high, and after 5 seconds Q2 goes high, and after another 6 seconds Q3 goes high, right? Likewise, once this one is completed, this one is starting, and once this one is finished, this one is starting, and it's finally its output is given to the Q3. Likewise, you can use them as cascaded one. So once this one completed, it starts, you can use its contact to enable another time. This is what is using as cascaded timers. So don't worry, I will upload all these files. You can try yourself, or you can refer the presentation slide and you can use by yourself, implement this by yourself, or if you face any difficulty, download the files that I'm sending, all these program files, then you can open in your computer like I have done. I have done in here. So you can try by yourself, but I recommend you to do this by yourself, just looking at my presentation slide. If any difficulty happens, then only you can download this project file and just open it and try by yourself. Another interesting use of timer is using cross-coupled timers. For example, if you want to develop a PWM signal, likewise, this kind of pulsative signal. So you have this T off time here. So whatever the desired off time you can use there, and this is T on time, right? So you can adjust either this time or this time, and the summation is all these 2 times, right? So you can make any arbitrary waveform using this cross-coupled timers, and this is quite interesting and it's a little bit confusing, but try to understand, right? So I have this start button here, which is this start holder system, and so I have 2 timers, and I have used this to generate this pulse output, my desired output, any desired duty ratio. So this is my output Q1. It is connected to the output of T1 time, right? So these 2 timers are connected in such a way that they are cross-coupled. For example, now the output of T on 2 timer, it is normally close contact is set to the input of the T on 1 time, and the output of T on 1 timer is set to the input of T on 1 time. So this is what happening. So I have defined this reset time as 5 seconds for the T1 timer, which means this delay, when it is starting, it is counting 5 seconds and turn on its output after 5 seconds, right? So it's a simple T on timer. So 5 seconds time, because when it is starting, this one is because you know T on 1 is 0 initially, which means this timer is off, right? Which means T on 1 is 0, which means this one is 1. So when you press the start button, when this is closed, the power comes here, and this is again, since this is 0 and this is 1, and power comes to here, the T on 1 timer start counting, and you can see T on 1 after 5 seconds, the T on 1 goes high, right? So when this is high, so that is output is set to the T on 2 timer. You can see when this is high, now the T on 2 timer start counting, because now this is 1 and its start is always 1, and this is 1. So T on 2 timer start counting. You can see now T on 2 timer starting from here, right? So after 3 seconds of T on 2 timer, this T on 2 output goes high. It is trying to set this output high, but the thing is, like, when it is set to high here, you know, like this is connected to the normal close contact. This one becomes immediately 0, which means T on timer will be reset, right? This one will be reset, which means this one becomes 0. T on 1 time becomes 0, which means T2 timer also becomes 0, which means so the same time it is getting high, and the same time it is getting 0, and the same time this T on timer also get reset to 0. So but the output is taken from T on 1 timer, so the output is like this. Here the both timers get reset after that. So what you can control here is you can control this off time period by using this defining this 5 second time. So it is the off time, this time delay, and the on time delay, this period of the output can be controlled using adjusting this one, right? So if you don't understand the concept, but still you can use this setup, And by changing these two values, you can change this waveform. So the sum of these 2 times is 8 seconds. This is that, right? So you can adjust this 5 second here by using this one, and adjust this 3 second here by using this one. So likewise, you can implement any arbitrary square wave type waveform, adjusting to any off delay and on delay. That is what we call cross-coupled timers. That's all about for the timers, and we will see some example of cross-coupled timer in a minute. Okay, now I am using a cross-coupled timers. So you can see I have TO1 timer and TO2 timer, and I have used this start button. That is the start of my whole system. When I press start, so my system will starting, and it is continuously generate that kind of arbitrary PWM signal at this Q1 output. So here I have defined this T off time. That is this is my turn off time. That is 5 seconds, and this is my turn on time of the output. That is 3 seconds. I have used both timers as T on timers, and from here I can visualize the elapsed time of T on 1 and elapsed time of T2 from this one. If I drag this a little bit, I can see all the outputs as well. Right, let me start the simulation now. When I press this one, you can see this is counting and still the output is 0. After 5 seconds, the output get high, and this is starting, and after 3 seconds, the output goes 0, and it is again starting, and after 5 seconds on 1, and it is remaining for 3 seconds, and off for 5 seconds, and on for 3 seconds. Likewise, by changing these values, you can keep this line turn on for even for same time period or any different time periods, whatever the times that you decide. This is how you're gonna use a pulsative output signal using cross-coupled timers. All right, now back to this PLC programming task. If I come back to the task number 6, now you can, the question is construct a ladder diagram to provide a flashing light on output Q1. This output should provide a 1 second on followed by 2 second off sequence repeating continuously. A power switch should be start and stop the whole system, simulate with graphical visualization, and verify your ladder diagram. So this is what we have done in cross-coupled timers. So 1 second delay and 2 second off, right? 1 second delay. Likewise, you can do this task by yourself. All you need to do is adjust these parameters, time delays, and then you can solve this task. I hope you have had the time to work on the other tasks as well in the previous lecture. And in task 7, it is asking yeah, so that is all about timers. So you can try this by yourself, then it will give you more understanding about timers. So far, do you have any questions of this section? Okay, looks like no one has questions, which means you have brilliant brains, understanding. Let's see how you gonna do in the exams and assignments. Right. So from this point onwards, I'm just giving you time to practice by yourself until 12 p.m. So we have 20 minutes. So this is the time you can just try this activity using Codices, this cross couple timers. And if you have any difficulty, you can just share the screen, ask me to share the screen of you, and I will help you to figure it out. Right. So now looking at this one and looking at the task number 6, try to complete this one within the class. And yeah, so the videos and the lecture notes will be uploaded to the LMS in due time. You can refer them and just work on this example number 6 in this tutorial, as well as this example that I have already discussed in my today's lecture. So if apart from that, if you need any clarifications, you can just find more YouTube videos in the internet regarding the timers and yeah, different types of timers using Codices. Refer those online resources as well. So that will give you more understanding and training for your PLC programming. So just to tell you, like without practicing these codings and everything by yourself, there's no way of becoming a PLC programmer. So therefore, just practice everything from the start, beginning, then you can just move forward. So that's all about this lecture, and next week we will discuss the counters, and you can refer these lecture notes after this session. Thank you.